This is the short version of practice problem number 2 from lesson 5, coordinate moves, and unit 1, rigid transformations and congruence. In this problem, you are to describe a sequence of transformations that takes trapezoid A to trapezoid B. So trapezoid A to trapezoid B. So how do you get trapezoid A over to trapezoid B and have trapezoid A cover exactly trapezoid B? Now, transformation means that you're going to move this figure with no bending or stretching. So however you get it over here, it can't bend in any way, it can't stretch in any way, it has to maintain the same form. So lots of ways to do that. So one way is to use a protractor and measure this angle from this horizontal line right here and this line that goes from this point on figure A to this point on figure A prime, which also matches this point on figure B. So that angle it measures 39 degrees. You could probably round it off to 40 degrees, but using that angle and also this length, you have to measure this length. You could describe this movement as moving figure A at an angle of 39 degrees and describe the distance that you move this image. The only issue is that this point right here has to land right on top of this point for figure B. Another way to look at it is to slide figure A up vertically. And so again, you have to slide it up so that this point is horizontal. This point right here is horizontal to this point on figure B, and then slide this image or this figure horizontally over to where it matches A prime. Second way to do that. In reality, you could slide this figure all around this page, and just as long as it lands on this point right here, so that you can then use a rotation to match A prime to B. It doesn't have to be a straight movement. So once I moved A to A prime, so then how far do I rotate? And I'm going to use this point right here as the center of rotation. How far do I rotate image A prime so that it matches image B? And you can measure that angle. It's 60 degrees. So this point right here is going to go to right here. And if you read up the protractor, that is a 60-degree rotation. So I'm going to use a couple circles. I'm going to rotate this point along this smaller circle, and I'm going to rotate this point up here along this larger circle. And they're going to rotate at the same time. They're fixed. They're connected. So rotate this over. Keep going. Rotate again. Keep going until it matches figure B. And then you can look at that rotation from here. This is 0 degrees. Up to here, this is 60 degrees. So it is a 60-degree rotation. So A prime to B is a 60-degree rotation. And here are the images that we started with. The problem just says describe a sequence of transformations that take A to B. So you could say that I translated figure A so that this point right here matches this point right here. Whatever path you take to get there, doesn't matter. It's still a translation. Normally we think of translations as being movements along straight lines, either diagonals or vertical or horizontal, but it doesn't really matter. And secondly, to get this figure, once it's translated to here to match B, it is a 60-degree rotation. And you could just say it is a rotation. So it's a translation followed by a rotation. That's the simplest way to state it.